Okay, so this video is going to focus on the vestibular system, which is a system found within the petrous temporal bone, which you can see here, sticking out laterally into the cranial base. And the vestibular system is going to detect sensory information, particularly within the head, so that's for things like motion, equilibrium and spatial orientation. And this is going to allow us to do a lot of things that you probably don't think about. That's things like keeping your balance, knowing where you are in relation to the outer world, the external environment, and even simply being able to remain upright. So to allow this to work, there's lots of different parts which are of the inner ear which are found within the vestibular labyrinth. So just to go over it again, this here obviously is your ear. This joined with the external auditory canal here. The external auditory meatus is going to form the outer ear. The middle ear here is going to be formed by the surface of the tympanic membrane and the ossicles here, and then the rest of it here is going to be your inner ear. So I'm going to speak about structures here particularly. So within your vestibular labyrinth, which is again located within the petrous temporal bone, there's going to be 5 different components. So 3 of these are going to be your semicircular canals, which are drawn here, and then there's 2 otolith organs which are also in this system here. So just going on to speak about the semicircular canals firstly. So that's them here drawn. So this one here is going to be your anterior semicircular canal. Behind it is going to be the posterior semicircular canal, and at a kind of 90-degree angle here is the horizontal semicircular canal. So these are sensory organs that are going to respond to angular acceleration. They're orthogonal to each other, so that means that they're all at right angles to each other, and this is going to allow them to respond to movements of the head in their own way. Be able to detect up and down movements like nodding, side to side movements like shaking your head, and left and right movements like tilting your head from side to side. So within these there's going to be cavities that are going to be filled with a fluid, and that's that fluid's called endolymph. So movement of the head is going to cause simultaneous movement of the fluid within these semicircular canals, and it's going to correspond to the movement in which the direction in which movement occurs, and that's going to let you obviously sense the direction. That's how you know what's happening. So the strength of rotation can also be determined by the amount of fluid that is moving and the speed at which it's moving as well. So it's going to move through these 3 semicircular canals here, and it's going to come into the ampulla, which is a big expansion at the bottom of them here, of each one of them, and it's really important because the ampulla is going to contain the sensory receptors of the vestibular system, which are these cells here, the hair cells. So each hair cell is going to contain stereocilia, which you can see here, extending up into the cupula. This is what this yellow portion is here. And these stereocilia are going to move in relation to the movement of the endolymph, which is going to be surrounding them here. So all this here is going to be endolymph, which, as I said, is going to move when the head moves as well. So the movement of these is going to release a neurotransmitter, which is going to be picked up here by the vestibular portion of the vestibulocochlear nerve. And then these cells here are just support cells as well, surrounding the hair cells, which are, as I said, the sensory organs of the vestibular system. So moving on to the 2 other organs within the vestibular labyrinth that I spoke about are the 2 otolith organs. So that's the utricle and the saccule, and these are also really important. So if you look here again, there's the 3 semicircular canals. This is the utricle and this is the saccule here. And these are going to be important in detecting linear acceleration. So I said here that the semicircular canals respond to angular acceleration. These here are linear, and they work in similar ways. So the utricle here is going to detect movement in the horizontal plane, and the saccule detects movement in the vertical plane, so that's things like going up and down in an elevator. Both of the structures have a macula, which is a sensory epithelium that's going to monitor the position of the head in relation to the gravitational pull via their hair cells and supporting cells, which are, as I've just described, are found within the semicircular canals as well. So just to give you a visualisation of this, this is going to be the macula here, the sensory portion. And the cells here, again, hair cells, support cells, this time are going to be embedded within a gelatinous substance. So this here, surrounding the hair cells and their extending stereocilia, is gelatinous. And this here is going to be an otolithic membrane, and the structures here are called otoliths. And they are actually calcium carbonate crystals. So basically movement is detected because these crystals here, the otoconia, these are otoconia, they are much heavier than this fluid surrounding them, so they're going to push down and cause compression whenever movement occurs. So unlike in the semicircular canals where movement and fluid direction occurs in the same way, this is different. So if movement of the head occurs in this direction, gravity is going to pull the otoconia down this way, and the weight of these are going to make the stereocilia of the hair cells respond to it, and that's going to trigger a receptor potential within these hair cells. Ultimately, that receptor potential is going to be relayed to the brain again through the vestibular division of the vestibulocochlear nerve.